Are you full, poor little dude? I want to show you something. Let's see if this works. There we go. Go. This is kind of disturbing. I just now found this right now. What I like to do is go to Google. I search for study, and then I put the time frame, the last week or the last month. And then I get the most recent studies. If you don't put the time frame, you get the definition of study, which is really useful. But right? So, and what did I find? I didn't find anything too interesting, I'm sorry, but if you drink hot tea, there seems to be an increased risk of esophageal squamous cell carcinoma, which is disturbing. I wouldn't immediately stop drinking hot tea, though. I want to look a little deeper into this. But the only thing I want to point out, I'm not going to get into the details of this, but do you see anything up here that looks at all familiar? If I stop moving around, maybe.
Want to highlight it?
Maybe. I don't know.
It says 95%.
Yeah. 95% confidence interval, this to this. So this is talking about the tea temperature. So they have a scale for the temperature, reported preference very hot. So this is probably the scale for preference. Very hot tea drinking, very hot versus very cold. So this is the interval for that preference scale. So it's just a fundamentally expected thing to do is to create confidence intervals for various aspects of your study. Why? Because it's the quickest way to look at it and go, oh, they're not very certain about that one. It's kind of a wide range versus this other one. Okay, maybe. So, and what Gallup does a lot, this should sound familiar to some of you guys. Some of you guys had this on the test. The Russians wanting to leave Russia. Of course, you can look at the Americans wanting to leave America. But if you go all the way to the bottom, you can look at the survey methods, and they talk about how many people they did. It was face-to-face interviews, which is neat. The age is so forth. But look here. The margin of sampling error. So the error was plus or minus 2.6 percentage points. Right, so that's basically exactly what we're calculating when we do just this piece. So they're telling me what the error was. So they report the absolute numbers they got, but at the bottom they always tell you how they got the numbers and what their error was. Maybe. So if their error was, 15, you're like, what? Why would you even print that? That's not good. Okay. All right. What I normally do, what I'm going to do, is we just did section 8.1. So 8.1 is confidence intervals for a mean with standard deviation known. The reason I skipped 8.2 for right now, we are definitely doing 8.2, is because 8.2 uses a different score instead of a z-score. Because what 8.2 does is it says, what the shit happens if I don't know the standard deviation? So tell me this. If I didn't know this, if I had to use S instead, should my interval be forced to be bigger or smaller? If there's something in here that I'm not sure about, should I have to catch more stuff or less stuff? More stuff to cover my ass for the fact that there's something I don't know. So what's really cool about section 8.2 is you're going to hate it at first because I have another chart for you. Yay. But basically, instead of putting the z-score, you're going to look on a different chart to get a score that's always bigger than the z-score. It just makes it wider, like you just said. There's something I'm not sure about, like, I'm not really sure where that fish is. You better get a bigger net, right? No? Yes? Just increase that so you're still as confident as before. All right, that's 8.2. I don't want to get to 8.2 because, again, like I said, it uses a different chart. 8.3 uses the same z-score chart. That's why I like to kind of go to 8.3 and then come back to 8.2. Okay. Stay with me now. So, considering that we have that z-score chart, and very often a z-score chart is either where the answer lives or it's where I look up a z-score I need for a situation. So, in order to use that, we all know it's got to be normal enough. And when I'm talking about means, what do I need to show that it's normal enough? Sample size has to be bigger than 30. I like it. Now, what do I need for percentages? For binomial situations, right? NPQ problems. Okay, this is going to get kind of nifty. So if I said, why are you allowed to use a z-score chart on a problem? You could just say, because the sample size was bigger than 30, like 37 for that last problem, right? That was for means, because they follow the central limit theorem. Well, what about percentages? We haven't even really talked about when is a percentage problem normal enough. I don't think I brought this, but do you remember that where it was flipping a coin and it looked like this? Remember that? There was in the middle was 7. Pretend like that's 7. There was that whole sheet where I was trying to get us to go from chapter 5 to chapter 6. Okay, maybe. Yeah, that one. Let me see real quick. Thanks, Linda. This sheet here. Oh, that's good. You see? Let's leave the Gallup stuff behind. Hot tea causing cancer. Okay. All right, now just subjectively, does that look like it's normal enough? Hell yeah. Shit yeah. Totally. It's symmetric. It's got the highest point in the middle. It's perfectly symmetric. Why is this one perfectly symmetric? Well, because the N and P were both 0.5 for this, right? So it makes sense it's perfectly symmetric. What's the smallest number on this problem? I flipped a coin 14 times. What's the smallest number of heads I can get? 0. So there is a wall at 0. You can't go below 0. And there's a wall up at 14. And in this case, the mean was right in the middle because it's 50%. You guys are with me? So this is a really cool idea. I love this idea. And I know I love a lot of the shit I say in here. That's why I teach this all the time. But, so for this situation, one wall was 0, one wall was 14, and the mean was right in the middle. So it's got room to grow, and then room to shrink. So that's why it comes out to be normal. What if I had a situation, let's do this. N is 14, just like this one, but P is 0.9. Can somebody help me out? What would the mean be then? 12.6. Is that cool? Just multiply those together, right? So now it would look like this. Here's 14. The mean would be 12.6, so the highest bar would be up there. It doesn't have as much room to go down symmetrically as it is going up and up and up and up and up and up and up, and there's a down. Does that look normal still? No.